My name is Raghavi Priya, Assistant Professor, Department of Computer Science and Engineering. So last time in lecture series we have covered the topics under Unit 1 in Virtual Reality and Digital Entertainment. So in this lecture series you are going to see about Unit 2 Visual Computation in Virtual Reality, and the topic is Fundamentals of Computer Graphics. So fundamentals of computer graphics. So a comprehensive introduction to the mathematical foundations, algorithms and techniques that power today's visual computing world. So what is computer graphics? So computer graphics is a field of study focused on creating, manipulating and displaying visual content using computational methods. So it combines mathematics, programming and artistic principles to generate everything from simple 2D interfaces to photorealistic 3D worlds. So this is the interdisciplinary field bridges the gap between the abstract mathematical concepts and tangible visual experience that users can see and interact with. So applications widely used using computer graphics are entertainment, medical imaging, user interfaces. So in entertainment covers movies, video games and virtual reality experience rely heavily on computer graphics for creative, immersive world and realistic characters that captivate audiences worldwide. So in medical imaging, there will be a 3D visualization techniques of CT scans, MRI data and surgical simulations, which helps doctors to diagnose conditions and plan procedures with unprecedented precision and clarity. So in user interfaces, every app and websites and digital interface you use daily employs computer graphics principles for layout, typography, icons and interactive visual feedback. So the graphic pipeline includes 3D models, transformation and finally rendering. So in 3D models represents the mathematical representations of objects using vertices, edges and faces in three-dimensional space. So in transformation, that is converting 3D coordinates to 2D screen coordinates through rotation, scaling and projection operations. So in rendering, applying lighting, shading and textures to create the final 2D image that appears on your screen. So the mathematical foundations include linear algebra, coordinate systems, trigonometry. So in linear algebra, vectors and matrices form the backbone of all graphics transformations, enabling rotation, scaling and translation of objects in space. So coordinate system, understanding different coordinate spaces, word, view, screen is essential for positioning and orienting objects correctly. So trigonometry consists of sine, cosine and related functions which are crucial for calculating angles, rotations and curved surfaces in 3D space. So core algorithm. So the core algorithm of computer graphics are line drawing, polygon filling, hidden surface removal and ray tracing. So line drawing consists of a Bresenon's algorithm, which is a line drawing algorithm efficiently determines which pixels to illuminate when drawing straight lines on discrete pixel grid. So next one is polygon filling. Scan line algorithm systematically fill the interior of polygons by determining which pixel lie inside the shape's boundaries. Hidden surface removal. Z buffer and other depth testing techniques ensure that objects closer to the viewer properly obscure those behind them. Ray tracing. Simulating the path of light rays from the camera through each pixel to create photorealistic images with accurate reflections and shadows. So lighting and shading. Illumination models ambient base lighting that eliminates and light scattered surfaces equally directions from rough surface. So shading techniques from simple flat shading to sophisticated shading, those algorithms determine how light interacts with surface material to create realistic data. So modern GPU architecture consists of parallel processing and programmable shaders. So graphics card contain thousands of small processors that can simultaneously calculate pixel colors. So programmable shaders, modern GPUs allow developers to write custom program shaders that control exactly how vertices are transformed and pixels are colored. So industry tools and technologies are graphics APIs, 3D modeling software and game engines. So computer graphics combines mathematical precisions with the creative expressions, whether you are interested in game development, scientific visualization or digital art, mastering these fundamentals open doors to endless possibilities. So practice the myth, code the algorithms, experiment with tools. Thank you.